Hi student, how are you? Hope you will be good and fine. Okay, dear student, today we are going to know some and solve some example of the first condition of the equilibrium. Already we discuss and study and know about the first condition of equilibrium, but today we are going to solve some example of the first condition of the equilibrium. Uh, let's see one by one. Okay, the first one. In this example, let's see carefully the subject, what they want. Okay, an object suspended from the ceiling. Ceiling mean like this part, uh, pulled by horizontal force of 24 Newton. Find the tension in the string and weight of the object. Like look at in this diagram, if you see the diagram carefully, they say that the original position, like here is a lamp or bulb, which are hanging to the ceiling, which to the ceiling, and after this is the original position. After that, they applied some force horizontally and moved the lamp from original position to this position. So they already given the force, like the horizontal force is given, which is equal to 24 Newton. So after this, they ask the question like find the tension force in the roof and also the weight, like how heavy the lamp is. So again, let's see. For example, this is the original position of the lamp. So when they pull horizontally toward positive x direction, so now this is the after pulling the force, this is the second position of the lamp. So here they make some angle which is equal to 53 degree. So they ask the question, find the tangent force here and also find the weight of the lamp and the force applied, which is equal to 24 Newton. Okay, let's find. Okay, this is the first condition of equilibrium. So when we see here, we will make the two component of the tangent force. Like the first component of this one, like this is the first component, which is equal to t of x, and the next component is this one. This is the t of y. So we know that t of x and f is opposite with each other. Both are horizontal, like this force and t of x, and we know that t of x in this case is equal to t dot cosine theta. So the applied force, which is equal to 24 Newton, and t of x is opposite. So on the horizontal side, first we find the summation of force, like this one, summation of force on x side, which is equal to 0. We know that about, like already we solved in the uh, first condition of equilibrium about this. Okay, so let's see summation of force on x side. So on the summation of force we have two types of force here. The first one is F, which is toward x's direction, and this is minus y because this is opposite to the applied force. This is equal to t of x, which is equal to 0. Now turn the F to this side or shift. So minus tx will be equal to minus f. So minus will be cancelled with this one. Now t of x is equal to f. So t of x is equal, t is unknown, and on this is equal to, we can also write is t of x is equal to t cosine theta, which is equal to f, and f is equal to 24 Newton. So just putting the value, so the theta is also given, which is equal to cosine 53 degree, and this is equal to 24 Newton. uh, so this is equal to t dot 0.6, which is equal to 24 Newton. When we divide 24 Newton by 0.6, so the tension will be equal to, the tension force will be equal to 40 Newton. So this is the tension force. Okay, the tension force now we find this is equal to 40 Newton. Now if we want to find the weight, let's see, weight is usually downward and T of y is upward direction. So again the T of y is positive, put this value, and now horizontal component we already find the from the horizontal component we find the tension force. In the horizontal component we had a two force, F and T of x. Now on the vertical side we have T of y and weight. So T of y is on the upward, so which we will take the value is positive, and weight is downward, which should be negative, so this is equal to 0. Or also we can write summation force on horizontal vertical side is equal to 0. So force on the vertical side is equal to T of y, this part, minus T of w, weight is minus w, so both are equal to 0. So this summation force is equal to T of y minus w. Now putting the value, so T is also be T of y is equal to T dot sine theta, which is minus, sorry, just shift the w to this part, so this will be equal to w. So T is now 40 Newton and sine 53 degree, which is equal to weight. So 40 Newton multiplied by 0.8, 40 Newton multiplied by sine 53 is equal to 0.8 is equal to W. If we multiply these two value, 40 Newton is 0.8, so this will give us 32 Newton is equal to weight. So now this is the weight, weight is equal to 32 Newton. So this is the answer. Okay, on the next page, try to solve. I will give you some homework. So same like this question, but here the applied force is unknown, only the weight is known. Let's see on the next example. Here, this is your homework, dear student. Okay, in this example, the theta is also given, tangent force is unknown, also the weight is known, but force is the applied force is also known. You will find these two forces, tangent force and the applied force. Just try to use the formula of the previous part or diagram, previous page, and solve this question. This is your home work, so try to solve this question. Okay, dear student, if you have any types of questions, so ask in your comment. Thank you so much.